Probability and Statistics, Normal Distribution, Part 4. This is the fourth in the set of videos on this channel on the normal distribution. If you haven't watched the first three, or if you're not really clued up on the normal distribution, it's preferable that you watch those before you watch this one. This one deals with finding the mean and standard deviation of normal distributions. In other words, what we're going to do is we're going to end up solving this equation for mu and for sigma in order to find their values, knowing the z values and the x values. Reversing the procedure done in normal distribution video 3. So a machine cuts logs into pieces that have length 2 meters. The lengths are normally distributed, which implies that they're not all exactly 2 meters, and therefore 2 meters will be the mean. So we know the value of mu, the mean is 2. The lengths of the logs are normally distributed, but we don't know the value of the actual standard deviation. 10% of the logs have lengths less than 1.95. So that is an x value, 1.95. That is the probability 0.1. Find the standard deviation. Now, if it's 10%, then it's to the left of the normal distribution. It'll be on the left-hand side, and to the left means the area to the left of that value will be 10% or 0.1. So that area is 0.1, means that area is 0.4, because the area of half the normal distribution is 0.5. Now, probability that x is less than 1.95 is 0.1. So now we know the z value, because all we have to do is look up the area for 0.4 and finds the z value on the z table. There's the z table, and that gives us 1.28. It's negative, that's fine, we can work with the symmetry. So a is negative 1.28. So now we have the z value is negative 1.28. We know the x value is 1.95. We know the value of mu is 2, so we can now substitute and solve the equation for the standard deviation. And that gives us the standard deviation is 0.039 meters. Stationery company makes pencils whose lengths are normally distributed with the mean mu and standard deviation sigma. Given that 10% of the pencils have lengths that exceed 17.4 centimeters and 25% have lengths that are less than 14.4 centimeters. So, if you consider the normal distribution, that percent having lengths exceeding must be on this side, so therefore that area is 0.1. 25% having less, that must be on this side, so therefore that's the 25%. Now, that's the a value of 0.4, and that's the a value of 0.25. How do we get that? Well, this z table works with areas between the mean 0 of the standard normal distribution and the actual z value, little z or a value. So this full area is 0.5, take away 0.1, so this area is 0.4. That's 0.25, take away from 0.5, and that's 0.25. So therefore that's the A.4, A.25. Now we can go to 0.4 and 0.25. We can go to the actual z-scores of 0.4 and 0.25 and find the values of z. We go to 0.25 in the body of the z table. We get 0.67, which means that that is 0.67. If we go to the body of the z table and look for 1.28, we get to look for 0.4, if we go to the body and look for 0.4, we get 1.28 as your z-score. So now from there we have simultaneous equations. We have the z-score, we have the x-score, which is 17.4 and 14.4, and we need to find mu and sigma. So there we are. 0.67 is related to the 14.4 length, so there it is there, and 1.28 is related to the 17.4 length. So now let's find both of those in terms of mu. There it is. And because it's mu equals, we can equate them to one another now. And we'll solve that for sigma. There we are. Sigma is 1.54 centimeters, so that is the standard deviation of the pencil lengths. Now all we have to do is take that, substitute back into either of those, and we get the value of mu, the mean of the pencil length.